Hey, welcome back to the bench. Good to see you again. Thanks for joining. Today on the bench I have a Ross 30, or it's an RE-3430 8-track player. This is a standalone unit, and I think these are kind of gaining popularity again because some people, they want to be able to play their 8-track collection, and they want a simple player to do that. And this kind of fits the bill. Now, I've done one of these before in the early days of the channel, and this is not the same one. This is a different one. This one came with both speakers, and it's actually in fairly nice shape. I did do some Danish oil on the cabinet to bring it back. This is actually a wood veneer rather than a vinyl wrap, and it looks not too bad. But so we're going to go through this, give it a service, make sure it's running 100%, and then pass it on to a new owner, somebody that can find some use out of it. So I got the speakers connected. These are, to tell you the truth, I think it's like a 4-inch speaker in here. I can feel the opening, and it's about, yeah, maybe 3 inches actually. Let me try measuring it. Let's just measure it for, let's do this one. Both the same? Yeah, they're both the same. So if I go from here to here, yeah, it's 4-inch speakers. Nothing to write to your grandma about. 4-inch speakers aren't the greatest, but we'll see. Might have a plan for these too. We're going to do some upgrades, but for right now, I have a test tape and Bay City rollers. Anybody remember these guys? Are they from Scotland? I can't remember. And what's the date? 1976. So yeah, I think they're Scottish. Look at the little tartan on these guys. But I remember seeing one of these characters recently on a show somewhere in the UK. I can't remember what it was. If I remember, I'll let you know. But anytime you put a tape in, check to make sure it's good. Let's plug this in. And right off the bat, we're drawing 1.5 watts. Actually, it went up quite a bit. Let's that drain down again. It was quite a bit higher when I first plugged it in. I think it's just capacitors. So 1.3 watts, and it's kind of slowly going down. Okay, so speakers are connected. Let's hit the balance center, tone center, and volume about a third. Here we go. Ooh. That doesn't sound good. We got stereo. We have track selection. We got a light out on track 1. Okay, so we got some work. We got scratchy pots, and we got a burned out lamp, and we got some. Actually, it's working a lot better than what I expected. Drawing about 5 watts and running. That volume control is very messed up. Alright, so let's go through and do service. Beauty of this is it has a schematic on the bottom. Not that we're going to need it. What do we got here? 4 transistors in the preamp, 8 transistors in the power amp, so 12 transistors total. Very basic power supply. Here, I'll zoom in and you can see it for yourself. A very basic power supply, bridge rectifier, filter, our motor, and then we have our 4 lamps with the switch. tape head preamp, volume control, and tape power amp, one for each channel, and headphone jack. It's pretty basic, very basic. So I expect a lot of these caps will be dead by now, and we're going to go through, make sure we don't have any cracked solders, and then we're going to clean the pots and service the mechanism, and then we'll get this thing out the door. Okay, let's have a look at the speakers. Made in Japan, so it's a treat to look at. So the back is perforated, so I took out all the screws. The back's perforated, so it's not a bass reflex speaker system. And inside we have a cheesy little 4-inch speaker, 2 watts rated. Now my plan for this is going to be a little upgrade. So we're going to go with a dual cone 4-inch speaker. I ordered these just for this project. And I'm wondering if it'll even fit the hole. It might not. It might be too small. But this has a tweeter built in. The driver has got a plastic cone on it, so it's more resilient, and it's got a suspension around it, so it's going to have a better response than what's in here. So let's get this one out and see if we can make this fit. It says it's 4-inch. Doesn't look like a 4-inch speaker. Looks like I might have got ripped off on this. Barely 4 inches across. Alright, so let's see what we can do here. Alright, so here's a look at what we're taking out. It's a typical Japan 70s speaker from, and this is what we have here. A tiny little magnet, tiny little voice coil, paper cone. So we got limited frequency response with this. Going to get some fairly good distortion when we get to the higher volumes. And look at the magnet assembly, just really weak. And this is what we're replacing it with. So this is going to make a huge improvement in sound quality for this little player. I don't expect it to be phenomenal improvement, but it is going to make a big difference. I'm wondering if there's any way to do any before and after. And I'm just thinking about different tones and stuff, putting it through the speakers and just testing it. Before and after kind of situation. But I think, I don't know, put down in the comments what would be a good way to test. And these were cheap. I got these on AliExpress. I can't remember what I paid for them, but it wasn't much. And I ordered them for this project. It says right here on the back, frequency response. Can you read that? Hope you can. Frequency response 90 to 20 kilohertz, 4 ohms. 4 ohms might be a problem, but I don't. We'll see how this thing drives 4 ohm speakers. It might not like it. Okay, that went a lot easier than I expected. That was just a drop-in replacement. Use the same hardware. Just wired the speaker wire back up to the terminals. And actually, this is actually a really well-built speaker enclosure. For what it is, they put a lot of effort into this thing. It's got bracing in the corners. It's all the corners are braced and glued. Just got to check it over, make sure that none of the panels or sides are loose. If it was, I'd be doing some re-gluing right about now, just to make sure that it's not going to buzz or rattle when we hit those bass notes. But I think this is going to sound a lot better than what it was when it came in. I'm just going to add some sound deadening, because just to keep any resonances down. And then we're going to reuse the same back. Now I was kind of sitting on the fence about this back. Cut a new one without the holes, or just leave the holes alone. We'll see how it sounds. I think the holes will be alright, but we're going to use it. And just put it back in and close this up. And then I'll get the other one fixed up as well. Okay, so I did the left speaker with a new driver. This one came from here. This one's still original, and I can actually tell a huge difference between the two. This one sounds a lot better than that. That sounds really muffled, and well, here, I'll show you. Left channel. It's muffled. So huge improvement in sound just from changing the driver out. Here's a tip for you. If you're ever struggling with these screws, they have this green thread locker all over, and what happens is I can turn the nut, but the whole thing's turning, and it's just, I can sit here all day and it won't come out. And it's not just the green, you get this in red and you get this in blue, the thread locker. And a really quick way to destroy that is just get a little butane torch and just give it a little heat. About that much. And then these just spin right off. There, just like that. Easy. Alright, now we've got the speakers out of the way. Let's get to the meat and potatoes of the matter here. So we've got to remove the back. We have 6 screws in the back, wood screws, and then we have all these screws in the bottom that need to be removed. A little instruction here. Remove chassis from cabinet. Unscrew the 4 screws mounting marked black when then the chassis is removed from the cabinet together with the front panel. So I just removed the 4 outside ones. Okay, get those screws out. Oh, I see what they're doing. Okay, so they got angle irons here, and I just got to remove 4 screws, and then the lid comes off, and then the base and the chassis stays together. So let's just do that. One thing about these Japanese built electronics is they're a lot better quality than the stuff that came at it later out of Taiwan. Okay, so you can just remove the lid, and we are in. So, ooh, look at that belt. Been shredding it. I wonder if that was me doing that. This belt. See, there's a skid mark here. It suffered some trauma for sure. Let me show you. You see, this belt has got sitting in one position for too long, and it's got a big gouge out of it. Plus it's got cracks. If I stretch it, you can see cracks. Not a very good belt. Not anymore. So we'll have to find a replacement for this. Noisy too. Why is it so noisy? I don't know, we'll figure it out. We'll figure it out. Now the electronics will be underneath the chassis, so we're going to have to remove everything here anyway. Pots are easy to clean. Electronics are underneath on a printed circuit board. So we'll have to dive into this. Alright, let's just go over a few things. I just opened this up and I'm looking at it, and a few things just jumped right out at me. So, we have our 4 lamps up here for track indicators, but we have a broken wire here. So this would explain why track 1 wasn't working. And you can see, I don't know if you can see this, but it's been pinched. It probably got pinched in the case. And this is the reason this got pulled off. It might have never worked from the factory, because I don't think anybody's been in this before, and I think this just got yanked off when somebody put the lid on, screwed it down, and this wire got ripped off. So this goes right to this grounding lug here. You can see there's 3 other wires going to it, or 2. I can see 3, yeah, 3. So I'll just reattach that wire and reroute the wire so it doesn't get pinched again. That's an easy fix. Shredded belt, well, we're going to have to clean all this up. I don't think the belt itself is garbage, because look at how it's got a memory now from sitting in that one position for so many decades. And this will never, plus it's got a huge gouge in it. I don't know why it shredded itself, unless the flywheel was frozen for whatever reason, but you know, the flywheel's not gummed up, it's not sticky. So I don't know, it doesn't matter. We're going to replace the belt. We have to clean up all the shredded shredded belt residue. Now, onto the power supply. This really irks me when I see this. You got the power cord coming in. There's no power switch, there's no fuse, and it goes to this terminal strip, and then it goes to the transformer terminals. So I'm going to remove these two connections on this terminal strip. I really hate seeing 120 volts or mains power next to the isolated secondary power. There's too much risk for a short here and danger of electrocution. So what I'm going to do is I'm going to remove these, and I'm just going to connect the wires directly to each other and then insulate with heat shrink. And I'm debating on whether to install an inline fuse or not, because this little transformer, I don't know if it has an internal thermal fuse. It might not, and there's really no protection. So I could like put a 1/2 amp fuse in this thing. This thing consumes like 5 watts when it's running, so it's really low power. But I really don't like seeing transformers unprotected, because they can fail, and it does happen. So on the secondary side, we have some issues as well. These diodes here, these hockey puck diodes, they're notorious for failing. I've seen a lot of these fail in the past. So it wouldn't be a bad idea to remove these diodes and install some modern silicon, some 1N4007s or something, you know, good for 1 amp. 1 amp should be fine for this. This thing really consumes low power until this solenoid kicks in. And when you hit your track select, what you're doing is you're putting power onto the solenoid, and the solenoid kicks in to click it to the next track. That's the only time you're going to consume heavy current, and it's momentary. But if somebody holds that button in and keeps the solenoid engaged, these diodes can overheat and short. And yeah, these, like I said, these aren't very good diodes. Another thing is, this cap here is a 2200, as you can see, and let's just measure it. I discharged it already, so we're good on our meter. If I connect the meter across the cap, I get 1900 microfarad and about 100 milliohms of ESR. Not a great cap. So we can replace this. We can upsize this to a 3300 at 16 volts. I'm going to measure the voltage across it, see what the voltage really is, because sometimes the voltage goes up to like 19. Let's do that right now. Let's plug it in and measure this, because I've seen this before where they put an underrated cap in the power supply. Here's our voltmeter. Let me zoom out. Let's see what we got here. Positive, negative. Yeah, it's over 16 volts. So I don't like it when they do that either. So we're going to upsize this to a 25 volt cap, and we're going to upsize it to 3300 microfarad to give it a better power reserve. Because when we kick in, let's do this right now. Let's kick in the solenoid, and we'll see how much it drops. It doesn't want to. There's the motor. I'll turn the motor on first. You see the power drops to about 14 volts. 8 volts. So it's got quite a bit of sag in the power supply. And a lot of current is drawn from that solenoid. So I wonder what the current is. We could measure that. That motor doesn't sound good either. We're going to have to lubricate the motor. Let me think about this. Let me see what kind of current this draws. And we could maybe insert a resistor in this red wire, because this is the main power feed. Insert a 1 ohm resistor and measure the voltage drop across it, and then we can see what kind of current this thing is drawing. Alright, so I have installed a 1 ohm resistor in series with the power feed for this tape deck. Got it connected across a voltmeter across it. So let's turn on the motor. And we're getting 160, 167 millivolts. So from that, it should be 100 and, what is that? I think the math is 167 milliamps. Let's do the math here. I equals E over R. 0.164, was it? Divided by 1. 164 milliamps. 166 milliamps. Let's try the solenoid. Yeah, we're drawing almost an amp. 1 amp. So IN4007s won't be enough. We're going to have to get a 3 amp diode in here because we're right at the limit. When that solenoid kicks in, we're drawing 1 amp from this power supply. So 3 amp diodes would be perfect in that application. IN4007s are rated at 1 amp, but they have a much higher peak current, and you don't want to risk that for continuous. Yeah, 3 amp diodes would be perfect, and then we'll have to upsize that capacitor in both voltage and rate capacity, and then we'll fix up the mains wiring portion of it, and then we're good. This cap here measures okay. I think it measured, this is a, I don't know what this cap does. This is, let's see in the bottom here. We can see on the bottom what this cap does. Yeah, this is a motor capacitor, 200 microfarad at 15 volts, it says. You probably can't see it from where you are, but that cap is to smooth out all the noise from the motor. So we want to make sure we have a quality cap here, something so that the motor noise won't get back into the power supply, into the amplifiers. 16 volts is adequate because when we put the power on, the voltage drops to about 14 volts, so a 16 volt cap will be sufficient here. Alright, finished the power supply. Did a number of things here. I removed these 4 vintage diodes. I don't know if you can read this. This is, what does this say? It's hard to read. You can see that. It says KS, I think, 05 or 06. Oh, here's a better one. KS05. I don't know. Find a data sheet for those and see what they're rated. I think they're just 1 amp diodes, but they're not very reliable. I've seen a lot of these fail. This cap, oh boy, what do I say about that? So, I replaced the 4 diodes with a bridge rectifier, and this one's rated, I believe, at 2 amps. I'm not 100%. I think it's higher than that, but I had a hard time finding a data sheet. And then I used a 3300 25 volt Nichicon. This capacitor here and this capacitor here, a world of difference. If I plug it in now, let me plug it in, I'll show you. You see the power goes up and then it comes back down to about 1.3 watts or so. This was at 1.5 before, so we're down 200 milliwatts alone just by replacing this cap. And you're going to say, well, how does that? Because, well, it's because this one's so leaky. This one was leaking internally, and yeah, it's done. I also reconfigured the mains coming in, bypassed these terminal strips completely because this is uninsulated and a shock hazard for anybody in here poking their hands. And I just put an inline fuse soldered to the end caps. You can do that. You can solder to the end caps of a glass fuse if you're careful. If you use too much heat, you might break the connection inside because it's soldered on the inside. But if you're careful with the amount of your heat, you can solder to the end caps. And then I just heat shrink it with some clear heat shrinking just so that we can see the filament of the fuse, and if it ever decides to pop. This is a 500 milliamp fuse. This thing, let's see here, when I powered it up, you're drawing like 60 milliamps on the line. And for example, even if I turn it on, it doesn't climb. And the real test is when I click into solenoid and watch how the power consumption climbs. And it goes up to 220 milliamps. So we're still half of what that rating of that fuse is. So that will protect the transformer or the solenoid. If for whatever reason the solenoid switch gets stuck and then this is energized continuously, I'm not sure which one would burn out first. I think the transformer would probably burn out first. But it had no protection before, now it does. So if this transformer fails or anything fails, even if this one of these diodes short, this fuse should pop. Okay, I removed the chassis from the base just for ease of service, and first look at the amplifier. There it is. It's all a printed circuit board, one board solution. So this is tricky. These boards are very, very sensitive to iron heat, and you look at them sideways and the pads want to lift, so you got to be careful with these. The good thing about this is it's wave soldered and all the leads are straight. They're poked through straight and they're cut off. On a lot of hand solder jobs, what they do is they get the lead, they cut it off and they fold it over. Like you can see, some of these are folded over, but not a lot. And the ones that are folded over are real, yeah, you're in real danger of lifting the pad or tearing the pad off. So 2 screws hold this side in. This side is held in just by a slot. So we remove these 2 screws, finagle the board out, and then we can flip it over. You got to be real careful. These connections will break. All these connections go back to our tone controls and balance controls and stuff. On this side, this is our speaker output. So take some photographs of where the wires go, because if you pull the board out and you start flipping it over, you're going to break one of these off sooner or later, and we don't want to do that. Then you're left kind of guessing where did that wire go. And so take some photos before you start work about where all these wires go. Some nice resolution photos so you can see. And then I'm going to flip this over, then we're going to start recapping this. We're going to recap this fully. I'm assuming there's dead caps in here, and I'll see as soon as I start pulling them out how much health they have left. All right, we are in. So tidy little amplifier. It's got all our power devices here. These look like germanium transistors, these 4. And then these electrolytics. All these electrolytics in here will be garbage by now. You got these black discs. These aren't capacitors. These are temperature dependent resistors, thermistors. And they're needed because germanium transistors are notorious for thermal runaway. And the hotter this gets, the more current it wants to hog. So what these little thermistors do is that they sense the temperature, ambient temperature, and as it gets hotter, it kind of turns down the bias. Kind of a self-regulating safety feature. These other transistors look like they're all silicon though. The little epoxy dome top transistors are tiny. Let's have a look. I don't know if we have part numbers on here. Yeah, 2SD72, that would be germanium, and 2SB405. So they're using NPN and complementary pairs for the outputs, and then capacitor coupled. Okay, 200 microfarad capacitor on the output. So that's what they're doing. Off of the, when this is running, we got about 14 volts. About 14 volts VCC. So, yeah. And then these other transistors are 2SC 536, 536. All these other ones are 536. So, pretty easy to substitute if you get in a pickle, except for these output devices. You're going to have trouble finding germanium output devices. Pull one of these out just as a for instance. So here's a 1 microfarad cap. Let's pull it out and see what it says. See if I can get it out without damaging anything. On these boards you really should be using solder sucker braid. That's probably what I'll do when I recap it. Okay. So what does this have to say? It's a 1 microfarad 16 volts. Oh yeah, we are wildly out of... Okay, so 1 microfarad at 16 volts, it measures 2.2 microfarad and it's got about 105 ohms ESR. So that cap is done. Way out of tolerance. Leaking like crazy. So I'll go through and replace them all and then I'll bring you back in. I got this front panel. This aluminum is detached on the right hand side here. It's completely the glue. Well, they used a double-sided sticky tape which isn't sticky anymore. So this side's loose. I tried prying it up here, but this side is really adhered solid. So I'm not going to fight with it because I'm just going to end up bending it and kinking the metal. And I don't want to do that. So I'm just going to inject a little bit of silicone neutral cure behind here. And that should bond it back down. So I think if I can lift this up just the slightest amount and get some of this underneath, then I can spread it around. I don't want to put too much because it's just going to ooze all out from under. So I don't know if you can see that blob under there. And let me see if I can find something to spread it with. And a wooden dowel. So I'm just going to get under here and just spread it around a little bit. Just to make sure that we should actually put some more in there. What I can do is this too. I can also do that and put it right where I want it. Way under here. Spread it around. One more shot, I think. Way over here on this side. Okay, I think I got plenty. Let me get rid of this. Get it away. I'm just going to carefully squeeze this down and then clamp it. Clamping it there. So that should... It's still loose here, but this side will be bonded. You can see I put a little bit too much, and I'll cut that off. Once it cures, I'll just cut it with a knife and get rid of it. And then, yeah, Bob's your uncle. So that should work out. So we got this motor. Let's service this motor. I don't know if I want to remove the motor and clean it, disassemble it. We can. It's a simple matter of disconnecting two wires. What do we have here? We have the red and blue wire, okay, going up through the chassis up to this terminal strip. You can remove these two wires, take the motor out, and take it out, disassemble it. But I don't know if we need to disassemble it. It is noisy, so let me apply 14 volts here on blue and red. We're drawing 170 milliamps. That's what we measured before when we did the resistor current draw test. About the same. It's quite noisy. What if we do? What if we just do a little bit of oil on the screwdriver trick and just touch the bearing and see if that just quiets that down? So let's get some oil. 3 in. Okay. That's about more than what we need, but this is going to be difficult. I can't see the bearing. Okay, well, I'm just going to try dripping it in. There's really no room for a screwdriver or a drop of oil. Okay, I hit it. Got it. It's in there. Let's try it now. See if it smartens up. This is negative, yes. Okay. There, completely silent now. Or pretty close to it. That's all it needed. Okay. Now that I got the motor spinning, I can just take a little bit of alcohol and touch it to the pulley. Just remove all the crap that's on the pulley, all the black rubber. It's really being stubborn, but look at all the stuff that's coming off. There's parts of it that just don't want to, and maybe if I scrape it. There we go. Maybe I'll show you what I'm doing. You can see this, there's a black line here that I can't remove. I'm just going to shave it out with the tip of the screwdriver. There. Just to clean off the residue that was stuck there. Okay, now I can use my cotton swab and give it a good polish and clean. Alright, okay, on to servicing the capstan and the flywheel. Now this was making a lot of noise before, but now it's silent. But it still needs to be disassembled and cleaned. And I think the easiest way to do that is just remove the entire assembly. Remove these 3 screws, and then the whole assembly just drops out. And then we can take it apart, clean it, lubricate it, and put it all back together as just to service it as an assembly. This thread locker is not even locking. All these 3 screws were loose, which isn't cool, and all that thread locker failed. Purple thread locker. Alright, so here's the assembly. You can see how gummed up it is on this bearing. So to service this, we pull out this E-clip. Do that right now. Just be careful it doesn't fling and disappear. Come on, there we go. Got it. And then we can take this apart, clean the bearings. There was a washer that fell out, and I think it was on here. Okay. For cleaning bearings, I like using tetrachloroethylene. This stuff here removes all traces of oil and grease, and then it leaves a clean surface that's not got any residue on it. So let's try this. Does a pretty good job, I think. A lot of the black stuff that you're seeing is just graphite. Graphite from on the tape. The tape is coated with graphite on the back as lubricant. And a lot of it transfers off of the tape onto the mechanisms. So it's no big deal. But we got to get some fresh lube on this. Got that clean. That's looking really good. Okay. I'll do the same with this, but with a Q-tip. Clean out the bearings, the bushings. Got all this crap in there. So there's a cup. You can't lubricate from the back because it's sealed. That's okay. We don't need it. Okay, look at this stuff that we're getting out. Get a clean one. Okay. 2 cleanings and I think we're good. All right. So we need oil on this bearing. And we need oil on this bearing. Okay, and we can now we need our E-clip. There. The E-clip is sort of dragging on the bushing. This side is good. Okay. Think that can go back in? Clean this surface too with some alcohol and a Q-tip or cotton swab and get rid of all the trash that's built up on here. You can see there's some trash stuck there. Clean all that off. You can use a cotton swab or these makeup pads. I get these makeup pads, they work okay, but they shred and they leave a lot of fuzz everywhere. So you can only use them in some places. But if you give this a good cleaning, you see the crap coming off already. All right, perfect. So this ratcheting mechanism here, this adjusts the head for the next track. You see it's got a profile on this star-shaped gear. It's like a cam. It's got a wave to it. I think it's cast that way. And the solenoid kicks in, and when it releases, it skips to the next track. You can see how the head goes up and down for each track. Now this is all adjustable. There's this adjustment for the height of the head. There's an adjustment back here for the tilt of the head. Yeah, so that's our 2 main adjustments. But we also have this thing here, this wafer underneath with these wires. That is the switch for the indicator lamps. And that was working with the exception of the one that was disconnected. So as it rotates, it makes a connection on one of these 4 pins, 4 wires. Okay, so what we need to do here is we need to clean this mechanism with pretty dried up grease on it. So let's get some cleaner. Let's try this stuff again, this tetrachloroethylene. Get it on a cotton swab. And let's manipulate the solenoid. Look at this stuff, we need to get it off here. It's kind of crusty with this ratcheting gear is cast. It's probably some pot metal. And it's probably some precision part. So let's get our own grease. Let's get our own grease on there. Let's just slather this thing up. Just work it, let it spread around. Okay, that's good. If you start getting dirt and crap in the cam follower, it can throw your alignment out for each track. Okay, that's good. Let's have a look at the head. Don't know how well you're going to see this. It looks kind of dirty. Some light on the subject. That's too bright. If you can see, there's quite a bit of trash stuck to the head. So I'll get in there with a cotton swab and some alcohol and clean that off. Okay, so I've taken the time to remove the screws from this cartridge slot, and it's just a metal plate that's folded over and it accepts the cartridge through the door. And just remove this so we can actually see what's going on underneath here. So on the underside of the cartridge door we have these springs. This is to hold the tape in position, and then there's a spring here as well and on this side. So it's to hold the cartridge in one position. We don't want it flopping around in the slot. And there's also a switch here. The switch here is the main power switch that turns the tape player on and off. And when you remove the cartridge, everything's shut off, except the power transformer is still connected to the line and still drawing power. It's just that none of the motor or amplifier is using any power. So that's what's going on there. So we can put this aside, get this out of the way, and then we can start to see what's going on underneath here. And I did this because I wanted to explain a few things. This here, this is our head, and its height is determined by what track is selected by the track selector. So as I cycle through the tracks, you can see it going up and down, and there's four different positions that it can rest on. And this here is a tape guide to hold the tape in position, because we don't want the tape moving, we just want the head moving. And you can see all the dirt and crap that's on this head. Let me zoom in, I'll show you. You can see all that. So that's pretty easy. We just attack that with alcohol, and you can see all the garbage comes right off. Give it a good scrub. You got corrosion and stuff like that, you might have to break out the very fine grit sandpaper, like maybe 600, 800, or 1000, and you want to polish the head with the sandpaper and then use finer grits to give it a shine. But I think this is okay. I don't know if that's corrosion, but it's being pretty stubborn. I'll play with that later. And then we have the track switch here. This is a couple pieces of brass, so you can't see it. A couple of pieces of brass that make electrical connection when the foil on the tape goes past, and that's what switches the solenoid, right? Every time a little piece of foil passes on these two contacts, activates the solenoid advances to the next track. Clean this as well. One thing I wanted to point out was this adjustment here. And if you look on the front panel, it says head adjustment. Okay, so that's this little black knob here. So what they're doing with that is it is a adjustment that goes probably 270 degrees from one stop to the other. And what they're doing is they're adjusting. I'll show you here. It's hard to see. Maybe if I turn this. Now if I go down, watch this part here, this tape guide. So I'll adjust it up and adjust it down. You can see how it moves maybe a millimeter up and down. And what that's doing is that's adjusting the tape path and it's adjusting the tape in relation to the head. So you're fine-tuning the head on the track of the tape. So when you do your head adjustments, you put this to the center position, and then you adjust your head with this adjustment here. This is your height adjustment. So you would center this adjustment and then adjust this for best sound quality out of both tracks. I just want to point out one good thing about this tape player is the head clamp is made out of steel, metal, and it's not a plastic one. I've seen plastic ones where they have a head clamp. This cracks over time and gets brittle, and then the head falls out. And then you have to either figure out a way to glue it. What I do is if it's the white nylon, I'll wrap it with floss and encapsulate that floss with her resin, either UV resin or epoxy resin. That's about it. And this adjustment back here, in the back, that's a azimuth. What that does is it adjusts the tilt of the head this way. If you look at the back, there's a screw here, and that's a pivot point. So, and then there's a steel pin that runs through, and there's a spring that holds it all down to keep it from flopping around and keep it on the down low. So I'm going to keep cleaning this head up, and then I'll put it all back together, and then we'll try doing some alignment. I don't think it was too far out of alignment, to tell you the truth, because when I was adjusting the head alignment knob here, it didn't really make much difference. So it's pretty close. I just got to get this head clean. There's something on there that's really rough. I don't know if that's a corrosion. I hope it's not corrosion. Okay, I'm going to go handheld here with the microscope. Just bear with me. I'm going to try and show you a few things on this head. Okay, so there is one of the heads. Where's the other one? The other one's below. Okay, so here's the bottom head. I don't know which track this is, left or right, doesn't matter. But you can see down in the center there's this line that's definitely split. That is the head gap. Okay, so we have three, it looks like three laminates, three steel laminates stacked on top of each other. And the head gap, where it's cut there and it's offset, here I'll move it. And then it's sandwiched between two brass plates, which is also cut. And then, so inside the head, the coil for this head is wrapped around those three laminates. And as the tape travels over that head gap, it creates a fluctuating magnetic field, which gets transferred to the laminates, which transfers to the coil. And then you get a very small signal on your coil, which you amplify and send out to your speakers. That's how that works. So you can see that offset is quite prominent. It's about half of the laminate is offset. I don't think it's supposed to be offset that much. I think it's supposed to be in line with each other, which is, I think, it kind of indicates a poor quality head. Let's look at the other one. This one here is a little better. You see it's still offset, but it's still, the head gap is yeah, so it looks like they had some problems with quality when they were making these heads. But I'm looking over here, and this, I was scratching at this. This is some kind of yellow crystalline stuff. You see the scratches I put in the head. I was using a razor at very light pressure, and so that's how easily this head scratches. Not that that's a problem. I could probably take a little bit of 1000 grit or 1500 grit and just clean that off and with it, smooth that out. It's not a big deal. It's not going to affect its operation because all of the head contact is right here in the center. Where is it? Right here in the center. See where it's nice and smooth, and it's kind of polished in line with the tape travel. On this side, we still have some, hang on here. On this side we have some pitting, You can see the pitting in the metal, and that's quite deep and prominent. Not that it's going to make any difference to the tape, other than these little pits will fill up with garbage and dirt, and they might scratch the tape as it travels past. You see I scratched a little bit on there too. So what I'm going to do is I'm going to take a little bit of fine grit sandpaper and just rub it over the head surface in line with the tape travel. So you got some bad pitting back here. It's way off. The head doesn't even contact here, but whatever this yellow crystalline stuff is, it's corrosive. I happen to think this is some of the adhesive they use in the tape to adhere the well, when they do the splice, the tape splice, and then they adhere the metal foil to the tape. There's some kind of adhesive they use that's gone crystalline and hard over time. So yeah, it's more pitting. You can see the pitting there. Okay, let me clean this up a bit, and then I'll bring you back and I'll try and show you what it looks like. Alright, I'm back, and I did some sanding. I wet sanded with 1000 grit, and then I wet sanded with 2000 grit. And you can see I didn't really get my lines, my sanding in line, but there's some rogue sand scratch marks there too. That's not a big deal. Let's look at the other one here. It's really hard to see the gap on these. Get the focus just right. I don't know if you can see, you can't see it. But it is there. And here's the other one. Now I did manage to get rid of some of this. This is pitting now. Kind of sanded out my scratches a bit, and you can see a residue of a few left, but that's all pitting. Okay, what's left is pitting, and this side here is pitting as well. Actually, it looks like the crystalline stuff is maybe inside the pits. I'm not sure. But that's outside of the tape path travel, like down here. The tape doesn't even touch this. This is bad pitting. But I think this is an improvement of what it was. These aren't very quality heads. They're not very high quality to begin with, and I don't know what kind of frequency response they have. Maybe up to 5 kilohertz or 8 kilohertz maybe. That might be the top end of these heads. They are not precision heads. Okay, so there it is. A little bit of sanding. I think it's made an improvement to the head. Would I do this on a high-end deck? Probably not, unless the heads were so worn or shot that the only option was replacement. You could try sanding and reprofiling this shape and getting the head back, but I don't know if you'd have much success. If you have a lot of groove wear in this head, this one you can look at it. It has virtually no wear on it. You can see it's pretty much flat from top to bottom. There is a little bit of a wave between the two heads, but I think it's pretty good. But you could profile, and you could regrind this and profile it and then sand it and bring it back, but I don't know if it, really extreme cases maybe it might work. Not something I want to spend a lot of time on, especially on a thing like this. It's not worth it. So I'm going to leave that alone. That's clean now, and I'm happy with the results actually, and we'll see how it sounds. I noticed one channel was a little weaker than the other, but that might be Amplifier. It could have been bad caps too. So we'll get this all back together. We'll test this and see how it sounds. I think in reassembly, I'm just going to use a little bit of blue thread locker on these threads. Whoa, I need that much. Okay, clean that up. And then we shouldn't have any more problems with loose screws. Let's see what kind of belt we have here. Ooh, 13-inch. Don't know if I have any 13-inch belts. I might have a 12.5. Boy, let me see what I have here. Okay, I checked through my inventory and I don't have any 13-inch belts. Largest I really do stock is about 11.5. The problem is, as the belt grows in size, so does the price. So I don't want to buy a bunch of random sized belts that are quite expensive for stock, that for things I might not ever use. This is a one-off thing. So what I done is I ordered a belt, and it's going to be here. This is quite a... I wonder if you'd turn it inside out, it would probably roll better. It would definitely bypass all that scarring that happened, because once this scarring goes over the motor pulley, you get a little bit of blip in the speed and it messes up the sound. Yeah, so like I said, I don't stock belts this size, and unless I need them, then I'll special order them, and they are getting difficult to find. But I'm going to run with this one for now, and then when the new belt does come in, I'll replace it, and everything will be kosher. So I think we're ready to put this back on the base and connect it back up. I think I'm done all the work I need to do. All the caps been changed. That went well. I still have one cap here. This is a motor cap. I could leave that or I could change it. I think it tested fine if I remember correctly. I could just leave it alone. And yeah, then we can do some adjustments. Just doing the testing phase here, and I already ran into a big problem. Big problem. It's not the tape deck, it's the tapes. So I was on the last track, track 4, and I was listening to the last song, and I was waiting for it to do the track change to track 1. It came along, I heard the solenoid click, but it wasn't a solid click, it was kind of a wimpy, failed click. And then it stayed on track 4, and it started playing track 4 again. And I was, what the hell's going on here? And if I look over here, I looked in the door and I could see exactly what was wrong. But right here is the foil strip that came off the tape. This foil, the adhesive has failed. See this? It's not sticky anymore. So this came off the tape, and that's our track advance foil, and so that tape has failed. This is, you're going to run into a lot of this with these 50-year-old tapes. This one was produced 1976, so that's put it at like 49 years old now. And the adhesive on they used sticky tape adhesive, and 50 years ago it was fine, but now it's all dried up and crusty. And yeah, so this is what we're up against with this old stuff. The media is failing, not the machines. So I had this actually on another 8-track I serviced and overhauled for a client, and he took the machine, he was listening to tapes, and then he says the machine stops working. Well, he brought the machine back, I took it apart, and guess what I found inside? I found another one of these foil strips in the head area. Tested the machine works perfect, but it was his tape that failed. So yeah, something you really got to be aware of with these 8-tracks is they are going to start to fail. Now, how do you repair this? You got to open it up. Actually, you need to advance the tape to the splice point, and then you need to re-adhere that with some kind of adhesive. I don't know what kind of adhesive you use for the tape, but it's got to be, you know, you don't want to gum up the heads, and but that's what we're up against. So I can continue testing this. It sounds okay. The head alignment is okay, because right here, if you can see this, that's where it sounds the best, and this knob is in its center position. So this is aligned correctly. I haven't done the azimuth yet. I assume it's good. I'm going to try it and adjust the head tilt this way to see if it improves the sound, but I don't think it will. But this one's ready to go. It doesn't actually sound too bad, and the controls are clean now. Balance is working. Everything's good. Okay, Disco Rock is working good. The BC Rollers tape is dead. The splice came apart and it was chaos inside the cartridge, so I pulled that one. I don't know if I'll repair it. Yeah, but that's the problem with these things. So this is all ready to go. I think everything's good here. I'm going to put the lid on this and call it a day. Not much else to say about it other than it's a dead technology, and I'm glad it's dead because it really doesn't have any place in today's world. But that's it for this one. Thanks for watching. See you on the next one. Take care.